This is our presentation timeline. We will start with introduction up until conclusion. For introduction, renewable energy derived from natural processes that are continuously replenished, such as sunlight, wind, hydro, biomass, and geothermal heat. Non-renewable energy comes from resources that will run out or will not be replenished in our lifetime. It is a linear energy production, while renewable energy sources are replenished naturally and continuously over relative short periods of time. It is a cyclic energy production. This is the examples of renewable energy and non-renewable energy. Moving on to the research background, as you can see here, for the hydro generation sources, there are 3% of incremental in 1996 and 2016 in Malaysia power generation sources. Malaysia has unique geographical advantage as it has a total length of river of 57,300 kilometers, and by TANGS in 2019, Malaysia has a lot of natural hydro resources potential. However, most of the fittest sites are already developed and utilized. It is limited amount of water flow and potential height. This is the hydropower classification. Hydropower ranges from large, medium, small, mini, micro, and pico. And for our main topic today is pico, which has the power output below than 5 kilowatts. Pico hydropower as renewable energy. Cities are served by pressured piping grids system to supply water from its sources to where it is needed. The piping system of single building, both for tap, supply, and drainage. A study conducted by Teruhisa Kumano et al. In 2018, he's assuming that proposed generating system is installed in an existing water pipe work system of a skilled building. From his study, he shows that he could generate as much as 91 watt in average and 370 watt in case of hazardous weather when more water can be utilized. Moving on to the problem statement, first, lack of renewable energy application for energy production within residential area. Second, PYHREDS does not link or ever existed in the designated building and residential area. Third, there is lack of implementation strategy for PYHREDS. The objective of this research, first, to determine the awareness of PYHREDS implementation in current building and residential areas in Malaysia. Second, to identify challenges, opportunities, and potential of integration between renewable energy and its application in buildings and residential area in Malaysia. And third, to outline the implementation strategy of PYHREDS for future application in residential areas and building. Moving on to the research methodology. To achieve the objectives of this research, for objective number 1 and 2, I've come up with methodology of literature review, questionnaire, and data analysis. And the third objective of this research, I've come up with prototype performance testing. For questionnaire, I've targeted 300 respondents and I obtained 172 feedbacks. The targeted community is AEC industry personnel and engineering students of Malaysia. For the prototype performance testings, I've conducted 3 tests, which is open circuit test, maximum power delivery test, and ability of charging test. And these tests were referred from the Pico Hydro Design Manual by A. Harvey et al. Moving on to research findings. For the rate of awareness on renewable energy, we scored a 3.94 of rate of awareness, which is 61% of them rate excellence on the awareness on renewable energy. For the prototype performance testing, the data is as shown. As the flow rate of water increases, the voltage will increase too. After first 15 minutes, due to the limitation working of the Pico turbine itself, the voltage stays at 12 volt. For the charging test, single Pico turbine could generate 1.8 watt per minute with the efficiency of 60%. To achieve a full charge battery, which is 133.2 watt, it takes 125 minutes to the battery be fully charged. Moving on to discussions, a utilization of electrical energy system store, which is a plug-and-play, has been proposed. The system of cyclic recharge and discharge will serve the residents on generating an alternative electric energy, and this could reduce the dependency on conventional energy generation. Moving on to the implementation strategy. For the implementation strategy, we have 5 phases, starting with conception and initiation, definition and planning, execution, performance and control, and lastly, project close. For each phases, we have each respective task. And on the right side of the table, it is the efforts that could be taken for the government, which to aid the implementation of Pico hydro turbine in residential and commercial buildings. First one, government may provide promoting efforts of the application of renewable energy. And the second one, establishment of policy and enforcement of law on obligation on implementing renewable energy technologies by the government. To conclude, 61% of the respondents rated excellent level on their understanding on renewable energy general knowledge, and the barriers that lead to this status is the challenges, which consist of high of cost installation, high cost of maintenance, technical complexity, lack of awareness, and lack of exposure towards the people. Renewable energy has its own opportunities, which can reduce combustion of fossil fuel, reduce gas emission, reduce pollution issues, and reduce the usage of non-renewable energy. And lastly, renewable energy could replace conventional energy eventually. So for the implementation strategy, a recommended plan for increasing the use of renewable energy technologies in residential sector. This strategy will serve as a reference to implement a micro hydro turbine in residential and building areas. Thank you very much for your attention.